What's up? It's translational training here. Alex Koss coming back at you with another another presentation. This one is on ketosis and beta oxidation, and I'm gonna go a little bit into feedback loops here because this is a big topic on Edg right now that Max is talking about, and I kind of wanted to piggyback on it. So first of all, what is beta oxidation? Beta oxidation is converting fatty acids into acetyl CoA to enter the Krebs cycle. So in in basics and just basic physiology, it's taking a longer chain carbon and breaking it down into a two chain carbon so it can enter the Krebs cycle to produce ATP. So let's get a little bit into it. It's going to be a little sciencey here, guys. So, first of all, we have our mitochondria here. This is the outer lining, this is the inner lining. So outside the mitochondria, we have fatty acids that float around with acetyl CoA bound to them. However, they cannot enter the mitochondria unless they have another aspect called carnitine. What helps the fatty acids and acetyl CoA enter the mitochondria is carnitine, and that is through CPT1, also known as carnitine palmitoyl transferase 1. So this combines the fatty acids and carnitine with between the outer and inner layers of the mitochondria membrane. So this is not inside the mitochondria yet, nor is it outside. It's in between the membrane. And the acetyl CoA is to the side. And then with these two combinations, now that the acetyl CoA is by itself and the fatty acid and the carnitine is by itself, they can recombine to get into the mitochondria because they can't just directly diffuse across. They need this transfer portal or this enzyme to help them get across. So once they get across, we have our fatty acid and acetyl CoA back again. What helps them get across is an enzyme known as translocase. Carnitine then is dissociated from the fatty acid and can just cross the membrane again. So carnitine can simply just diffuse from the inner to the outer membrane again. Physiology is weird. There are certain laws and certain things that you must abide by. Sorry about that. But now we have our fatty acid and our acetyl CoA inside of the cell. So what happens from here is we have acetyl CoA dehydrogenase. What this does is this converts our fatty acid acetyl CoA into an enol CoA. And by doing this, we add a hydrogen from an FAD and make it into an FADH. If you know a little bit about metabolism and physiology, you know FADH is one of the transporters that moves on over here to the electron transport chain, our ETC. And this drops off a hydrogen in complex 1 or 2. I've